This is BMAT 2021, Section 2, Question 3. So we have an object of mass 5 kilograms falling through still air. The air resistance on this object is 50 newtons, and we have to work out which statements are correct. So before we look at any statements, what I like to do in these sorts of questions is just draw a little diagram, a little force diagram, to make things in the future easier to work out. So here is our object. We know it's got 5 kilograms of weight. The air resistance is 50 newtons. What is going to be our downward force? Well, that's just going to be our weight. So to calculate that, we have to do our mass times our gravitational field strength. So that's 5 times 10, or 50 newtons of weight pulling us down. So let's look at our first statement. The object's acceleration is 10 meters per second squared. How might we calculate acceleration knowing some of the forces that we know here? Well, we can use a nice equation, force equals mass times acceleration. So if we calculate our overall force, it's going to be in this downward direction as we're falling downwards, so we're going to be accelerating down. That's going to be 50, take away our upward force of 50 to give us a resultant force, and that's going to be equal to our mass, which is 5 times acceleration. So 0 equals 5 times acceleration, meaning our overall acceleration is 0 meters per second squared, not 10. This is an incorrect statement. Our second statement is there is no resultant force on the object. So what does this mean? What is the resultant force? Well, that's just the total net overall force on our object. So that's going to be our downward force, take away our upward force, or vice versa. So in this case, we're just going to have 50, take away 50, which is 0, showing we do have no resultant force. So this statement is correct. Our final statement is that the object is travelling at its terminal velocity. What is terminal velocity, and how do we get to a terminal velocity? So this is the max speed, essentially, that something can reach, say, as it's falling. And this occurs when the resultant force is 0. So there's no stronger force on the bottom causing it to accelerate further, and there's no force pulling it upwards to cause it to decelerate. These must be equally matched to keep it at a terminal constant velocity. And as we've already established, we don't have a resultant force. Therefore, we must have reached our terminal velocity. So this one is also correct. And as only 2 and 3 were correct, our final answer is G.